There are advantages and disadvantages to twisting wires before using wire nuts. One advantage of not twisting wires before using wire nuts is faster installation because it eliminates the time-consuming task of twisting wires together. Another advantage is improved torque distribution because wire nuts rely on compression to create a secure connection, and twisting can interfere with this compression. Not twisting the wires allows for more even torquing, resulting in a stronger hold. An additional advantage is less damage to conductors, since twisting wires can damage the copper strands and weaken the connection. Avoiding twisting minimizes this risk. And finally, compliance with manufacturer's specifications, because most wire nut manufacturers state that their products are designed to be used without twisting the wires. On the other hand, the disadvantages of not twisting wires includes the potential for loose connections. If the wires are not properly aligned or compressed in the wire nut, a loose connection can occur. Also, there is an increased risk of arcing, because a loose connection can create a high resistance path, leading to arcing and potential fire hazards. It can also be difficult with larger wires because large gauge wires, such as 10 American wire gauge or larger, can be difficult to insert into wire nuts without twisting. Finally, there is the consideration for code requirements, because in some jurisdictions, electrical codes may require wires to be twisted before using wire nuts. For most residential and commercial electrical applications, it is generally safe and acceptable to use wire nuts without twisting the wires. If you are concerned about the potential for loose connections, you may choose to twist the wires before using a wire nut, especially for larger wires or in critical applications. Always follow the manufacturer's instructions and local electrical codes for the specific wire nuts and installation conditions. Ensure that the wire nuts are properly torqued and seated securely to create a reliable and safe connection. When using wire nuts, several key factors contribute to a secure and reliable electrical connection. Firstly, selecting the appropriate size and type of wire nut for the gauge and number of wires you are connecting is critical. Manufacturers provide charts and guidelines to ensure the wire nut can properly accommodate the wire combination. Secondly, preparing the wires properly is essential. This includes stripping the insulation to the correct length, usually specified on the wire nut packaging. Make sure to remove any nicks or damage to the conductor, as these can create weak points and increase resistance. Thirdly, when inserting the wires into the wire nut, ensure they are aligned parallel to each other and fully inserted so that the stripped ends are well within the wire nut's internal threads. Applying firm, even pressure while twisting the wire nut clockwise will create a tight mechanical connection. Fourthly, proper torque is vital. Over-tightening can damage the wires or the wire nut itself, while under-tightening can result in a loose connection. Many electricians rely on feel, but using a torque screwdriver with the manufacturer's recommended setting is the most precise method. Fifthly, after installation, it's important to perform a pull test to verify the connection's integrity. Gently tug on each wire individually to ensure they are securely held within the wire nut. If a wire pulls out, the connection is not secure and must be redone. Sixthly, always refer to local electrical codes and regulations. Some jurisdictions may have specific requirements for wire nut usage, such as requiring a certain number of twists or prohibiting their use in certain applications. Finally, regular inspection of wire nut connections is a good practice, especially in areas prone to vibration or temperature fluctuations. Look for signs of corrosion, overheating, or looseness, and address any issues promptly to prevent potential hazards. For stranded wire, the debate about twisting before applying a wire nut is more nuanced. Some electricians argue that twisting stranded wires helps to compact the strands, making them easier to insert into the wire nut and creating a more uniform contact surface. This can be particularly beneficial for larger gauge stranded wires, which tend to fray more easily. However, other electricians contend that twisting stranded wires can damage the individual strands, reducing their overall current carrying capacity and potentially leading to premature failure. They advocate for inserting the straight and twisted stranded wires directly into the wire nut, relying on the wire nut's internal design to create a secure connection. Ultimately, the decision of whether or not to twist stranded wires before using a wire nut often comes down to personal preference and experience. However, it is important to note that some wire nut manufacturers explicitly recommend against twisting stranded wires, as it can interfere with the wire nut's intended function. Always consult the manufacturer's instructions for the specific wire nut you are using to ensure proper installation. The materials used in wire nuts play a significant role in their performance and safety. The most common materials are a thermoplastic or thermoset plastic shell and a conical metal insert, typically made of zinc-plated steel or copper. The plastic shell provides insulation and protects against accidental contact with live wires, while the metal insert creates the mechanical connection between the wires. The choice of plastic material affects the wire nut's temperature rating, flammability, and resistance to environmental factors such as moisture and UV radiation. Higher-grade wire nuts use plastics with higher temperature ratings, making them suitable for use in demanding applications such as lighting fixtures and electrical panels. The metal insert's material and design influence the wire nut's ability to grip the wires securely and maintain a low-resistance connection. Copper inserts offer superior conductivity and corrosion resistance compared to steel, but they are also more expensive. The insert shape and thread pattern are also critical for ensuring a reliable connection. Some wire nuts feature ribbed or knurled inserts to enhance grip, while others have deeper threads to accommodate a wider range of wire sizes. In addition to the basic materials, some wire nuts incorporate special features such as sealant-filled caps for use in wet locations or spring-loaded insets for improved vibration resistance. These specialized wire nuts are designed to address specific application requirements and enhance overall safety. When selecting wire nuts, it's important to consider the environmental conditions in which they will be used and choose a product that is appropriately rated for those conditions. Factors such as temperature, humidity, and exposure to chemicals or UV radiation can all affect the long-term performance and reliability of wire nut connections. Using the correct tools for wire nut installation is crucial for ensuring a safe and reliable electrical connection. The most essential tool is a pair of wire strippers, which are used to remove the insulation from the ends of the wires without damaging the conductors. It's important to use the correct gauge setting on the wire strippers to match the wire size, as using the wrong setting can either nick the conductor or leave insulation behind. Another useful tool is a lineman's pliers, which can be used to twist wires together before inserting them into the wire nut, if desired. Lineman's pliers can also be used to create a hook on the end of the wire for easier insertion into the wire nut. A screwdriver or a nut driver is necessary to tighten the wire nut onto the wires. It's important to use the correct size screwdriver or nut driver to match the wire nut's head, as using the wrong size can damage the wire nut or make it difficult to achieve the proper torque. As previously mentioned, a torque screwdriver is recommended for achieving precise torque, especially in critical applications. Finally, a voltage tester is an essential safety tool for verifying that the power is off before working on any electrical circuit. A non-contact voltage tester can be used to quickly check for the presence of voltage without having to touch any wires. In addition to these basic tools, there are also a number of specialized tools available for wire nut installation, such as wire nut twisters and wire nut installation tools. These tools can make the job easier and faster, but they are not essential for achieving a safe and reliable connection. Regardless of the tools used, it's important to follow the manufacturer's instructions and local electrical codes to ensure proper wire nut installation. Several common mistakes can lead to unsafe or unreliable wire nut connections. One of the most common mistakes is overstripping the wires, which exposes too much bare conductor. This can create a shock hazard and increase the risk of arcing. The correct amount of insulation to remove is typically specified in the wire nut packaging. Another common mistake is understripping the wires, which leaves insulation inside the wire nut. This can prevent the wires from making proper contact and create a high-resistance connection. Using the wrong size wire nut is another frequent error. Wire nuts are designed to accommodate a specific range of wire sizes and numbers of wires. Using a wire nut that is too small can result in a loose connection, while using one that is too large can make it difficult to achieve proper torque. Failing to tighten the wire nut sufficiently is another common mistake. A loose wire nut can create a high resistance connection, leading to overheating and potential fire hazards. It's important to tighten the wire nut until it is snug, but not so tight that it damages the wires or the wire nut itself. Another mistake is neglecting to perform a pull test after installing the wire nut. A pull test verifies that the wires are securely held within the wire nut. If a wire pulls out, the connection is not secure and must be redone. Finally, failing to follow local electrical codes and regulations can lead to unsafe and non-compliant installations. Always consult the local electrical code before performing any electrical work. Wire nuts are not a universal solution for all electrical connections. There are certain situations where other types of connectors may be more appropriate. For example, in high vibration environments such as in machinery or vehicles, screw terminals or crimp connectors may offer a more reliable connection than wire nuts. Screw terminals provide a mechanical clamping force that is less susceptible to loosening due to vibration. Crimp connectors create a permanent, gas-tight connection that is highly resistant to vibration and corrosion. In wet locations, such as outdoors or in bathrooms, sealant-filled wire nuts or waterproof connectors are necessary to prevent moisture from entering the connection and causing corrosion or electrical shorts. Sealant-filled wire nuts have a gel-like substance inside that seals the connection against moisture, while waterproof connectors use rubber gaskets or O-rings to create a watertight seal. For connecting aluminum wires to copper wires, special connectors are required to prevent galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The aluminum wire corrodes, leading to a high-resistance connection. Alumicon connectors are specifically designed for connecting aluminum to copper wires and feature a tin-plated aluminum body and a corrosion inhibitor to prevent galvanic corrosion. In high-temperature environments, such as in lighting fixtures or near heating appliances, high-temperature wire nuts or connectors are necessary. These connectors are made from materials that can withstand high temperatures without melting or degrading. Finally, for connecting multiple wires together in a compact space, such as in a junction box, push-in connectors or lever connectors may be a more convenient option than wire nuts. Push-in connectors allow you to simply push the wires into the connector, while lever connectors use a lever to clamp the wires in place. Both types of connectors can save space and make wiring easier. In conclusion, the decision of whether or not to twist wires before using wire nuts is a matter of debate among electricians. While twisting can help to compact stranded wires and create a more uniform contact surface, it can also damage the individual strands and interfere with the wire nut's intended function. Ultimately, the best approach is to follow the manufacturer's instructions and local electrical codes, and to use good workmanship practices to ensure a safe and reliable connection. When selecting wire nuts, it's important to consider the environmental conditions at which they will be used and choose a product that is appropriately rated for those conditions. Using the correct tools for wire nut installation is crucial for ensuring a safe and reliable electrical connection. Avoid common mistakes such as overstripping or understripping the wires, using the wrong size wire nut, or failing to tighten the wire nut sufficiently. Remember that wire nuts are not a universal solution for all electrical connections. In certain situations, other types of connectors may be more appropriate.